Hello and welcome back to our video class here at CSEC Math Tutor. This is part 2 of a two-part lesson that we started on volume, capacity, and density. In the first lesson, we looked at how to calculate the volume of cubes and cuboids. We also explored what volume, capacity, and density were, how similar they are, and how different they are, and how we can find the volume of an object by determining the cross section and multiplying the cross section by the length. And so this lesson, as we say, is a follow-up. And in this lesson, we're going to be solving problems related to volume that deal with the other types of shapes that tend to come on your exam. So we're going to look at our first question. First, let's review some of the formula that we use. For a cube, we have the volume is the cube of any side. And for a rectangular prism or a cuboid, we simply multiply the length by width by height, or the base, the area of the base times the height. For a sphere, 4/3 pi r cube. And for a circular cylinder, we use pi r square height. We're going to be using this a bit. And we have for the cone, 1/3 pi r square height. And for the square pyramid, 1/3 a square, which is the area of the base times the height. So let's go to our first question. Now we're looking at the circular cylinders. They tend to pop up often on your exam, so you should be very familiar with them. In this question, we're asked to calculate the volume of tank B. Let's read up here first. The diagram shows two cylindrical water tanks, A and B, and tank A has a diameter of 8 meters and a height of 5 meters. Both tanks are filled with water. All right, so let's calculate the volume of tank B for a cylinder. We know that the volume is, we calculate the volume using pi r square height. So we apply that here. So we are going to use our 3.14 for pi times the radius square, and the diameter here is 8, which tells us that the radius is 4. So times 4 square times the height, which is 5. And that gives us 4 is 16 here. And 5 times 16 is 80. So that gives us 80 pi, which is 80 times 3.14. And that gives us a volume of 251, when you punch that into your calculator, 251.2 cubic meters. So that's the volume of tank B. Feel free to always stop the video to rewind and go back to the question to make sure that you understand. I'll be going through them as thoroughly as I can, but at the same time, you may not get it while I go through it. So it's important to go back and rewind and watch again. The second part asks for the second part says the area of the base of A is 314 meters square. So we are supposed to calculate the length of the radius of tank A. So notice here that the area of this base, that is this is the base, and the area of this base is 314. And we can use the formula for a circle. The circle's area is given as pi r square. That's how we calculate it. And so using the same 3.14, then 3.14 r square gives us the area, which is 314. Dividing that, then we know that r square is equal to 314 divided by 3.14, which gives us 100. And then r is the square root of 100, which gives us 10 meters. So the radius here is 10 meters. And so the last part here, part 3, is to calculate the height of tank A. Now we're told that tank A holds 8 times as much water as tank B, and we're supposed to use that to calculate the volume. So we're going to use the same formula here, pi r square height, because that is how we calculate the volume of a circular cylinder. So pi r square height gives us 8 times the volume of tank B, and that means 8 times 251.2, which means now that the area of the base times the height. The area of the base was 314, so 314 are 8 times the height, which we don't know, gives us 2000. When you multiply it out, 8 times 251.2, 2009.6. And dividing that, we end up with h is equal to 2009.6 divided by 314, and that gives us a height of 6.4 meters. So that is how we approach this kind of question, using pi r square height. And here we use the fact that the area of a circle is 314, is pi r square to calculate the radius, and then apply the same pi r square height to calculate the height of this larger tank. Let's look at our next question, which is slightly different but similar. Diagram below shows, and note importantly, not drawn to scale, shows a block of wood in the shape of a semicircular prism. The cross section of the prism is a semicircle. That's here. So here's our semicircle. This is the cross section, and the question went far enough to tell us that this is the cross section. So our aim first is to, it has a diameter of 30 centimeters, the length of 1.2 meters. So we are supposed to calculate first the cross-sectional area. And the area of the cross-section, since it's a circle, then we're going to be using pi r square. So pi r square gives us the area of the circle. But in this case, notice that we're using a semicircle, so we need to divide that by 2, whatever we get. Notice that our radius, this is a diameter, our radius is half the diameter. So our solution is going to be 3.14, that's what we're using, times the radius square, which is 30 divided by 2, that's 15 square. And that divided by 2 because we want half of it. All right. So punching that into your calculator and dividing by 2, we get 353.25 centimeters square. But notice that our question had said something important, and you have to make sure that you pay attention to these things when you're doing your questions. We are supposed to answer correct with 3 significant digits, significant figures. Now notice that there are 1, 2, 3, 4, 5 digits in this answer, and significant figures are counted from the front of the number here. So we are going to count 1, 2, 3 and decide what to do with the rest of it. Here we apply normal round off rules. So 353, that is less than 5. So we just round this off as 353 centimeters square. So those are our 3 significant figures. Remember, when you're doing your calculation, to pay attention to the way in which the question requires you to write your answer, because there's a mark for that part as well. All right. So we have found the area of the cross section, and the next part now is to calculate the volume of the cube. Now remember, the volume is equal to the area of the cross section multiplied by the height or the length. So the area of the cross section here is 353, and we're going to multiply that by the length. Now notice that the length there is 1.2 meters, but this answer here is in centimeters square. So when you're doing your question, you cannot work it with mixed units like this because it's going to give you an incorrect answer. So what you need to do is to bring both of them to the same unit. So look at your answer. Your answer is in centimeter cube. So this 1.2 meters needs to be rewritten in terms of centimeters. So 353 times, how many centimeters make a meter? 100 centimeters make a meter. So we multiply that by 100. And so our solution becomes 353 times 120. And so once you punch this multiplication into your calculator, you should get 2360. 42,360 centimeter cube. Again, pay attention to the fact that you should write it in three significant figures. So we count our three significant figures from the front: 1, 2, 3. And then we decide what to do with the number afterwards. It's a 6, which means it's 5 or more. So we add 1 to this. So we have 4, 2, 4, and replace those with zeros. So our answer becomes 42,400 centimeter cube. And that is how we handle this type of question. Oftentimes you will often need to modify the formula that you have to answer your questions. That's not a difficult thing. So here we notice that this was a semicircle, so you shouldn't just go use the formula for the area of a circle and not half it, things like those, to make sure that you have to change your units, pay attention to those things, and to pay attention to how you write your answers after you do your calculations. Let's go on to our other question. This is a very interesting one where we have a diagram which shows an open cylindrical container. Notice it says container, which means that it can hold stuff, made of metal with a base and uniform thickness throughout. That's important. It says the thickness is throughout. And so we're given two numbers, and notice it's in bold, uniform thickness throughout. All right, the length of the container from the top to the bottom on the outside is 120 centimeters, and it has two radii. Radii is the plural of radius. So we have an inside radius and then radius to the outside, so 14 and 15. We are asked to do some calculations here. So let me do a little mark here. So this radius would be 14, and this radius to the outside here would be 15. All right, now that I've put that in, it says show that the capacity of the container is 73,304 centimeter cube. Now capacity is the same as volume, but capacity is inside volume. That means how much the container can hold. So when you're calculating capacity, in this case where you're given two different radii, you have to use the radius that relates to the inside of the container. That is the part of the thing that deals with how much it can hold. So if it's a bottle, you're dealing with how much the bottle can hold on the inside, or a drum or something of the sort, and not the entire drum itself. So we're going to use the 14. So remember now, our formula for calculating the volume of a circular cylinder like this is volume is equal to pi r square height. Now we have our pi, which is 22/7, and we have our radius, which is 14, so 14 square, and our height. Now the question said the thickness is uniform thickness throughout. Notice from the top to the bottom is 120, but the container in the part that it has on the inside doesn't go all the way to the bottom. Otherwise, whatever you put in there would run out. So stops here, and since it's uniform and the difference in the radii 14 and 15 is 1 centimeter, then we understand that the interior height here is 120 minus 1, which is 119 for this height on the inside. So we multiply that by 119, and once you do your calculations, punch it in. We could do a bit of the calculation here. 22/7 times 14 times 14 times 119, and that gives us, do a little bit of division. 22 times, this is 2, so 2 times 14 is 28, times 119. And once you do that calculation, you will see that you get that 73,304 centimeter cube. So there we go. That's part A. Part B, or part C rather, this question has been modified. The parts that don't relate to air to volume have been taken out. So determine the volume of material used to make the cylinder. So if we're going to find that part, then we need to find the entire volume of the object and then subtract the internal volume. So here we go. So we're going to use pi r square height again. And subtract from that the 73,304 that represents the volume of the inside. So pi r square height now using 22 over 7 times the radius square. Now we're using the entire container, so the radius is now 15, times the height, which is now 120, and minus 73,304. So I'll give your calculator some work. And once you do that, you will get 84,857 minus 73,304, and that gives you an answer of 11,553 centimeter cube. Now for the third part here at D, we are told that density is equal to mass over volume, and we're asked to use this density. The material, given that the density of the material used to make the container is 2.2 grams per centimeter cube, this is how we calculate density. We divide mass by volume. And so here then the mass which we're asked to find would be equal to volume times density, which means that we simply multiply our answer here, 11,553 times 2.2. And that gives us an answer of 25,417 grams. But the answer wants it in kilograms. And for our conversion purposes, 1,000 grams make a kilogram. So we divide this by 1,000. And so dividing it by 1,000, we end up getting 25.4 kilograms. That takes care of this question. Now let's go to another question that looks at a different type of figure. Here we're dealing with a trapezium-shaped object, and PQRS. We have the dimensions here. So PS is 12, QR is 6, PQ is 15, and the depth here, ST, is 3. So first we're asked to calculate the area of the trapezium. That's PQRS. And the area of the trapezium is calculated using the formula half the height times the sum of the parallel sides. So we write that up, and half times h, we're using 15 as the h. The height is the distance between the parallel sides. So it doesn't look like a height here, but when we say height, we mean the distance between the parallel sides, or the vertical distance between the parallel sides. Here, that's 15. And times the sum of the parallel sides, now that's 12 and 6. So 12 plus 6 is 18. So it's half times 15 times 18, which gives us 9 times 15, which is 135 centimeters square. So that becomes our height. And now we want to find the volume. So part 2, given that ST is 3, calculate the volume of the block of metal. So we know that the volume is equal to the area of the base times the height or length. So we're going to multiply this area of the base, 135, times the 3, which is the depth right here. And that gives us a volume of 405 centimeter cube. All right, the third part says the block has a metal of 1.5 kilograms, and we want to calculate in grams the mass of 1 cubic centimeter of metal. So essentially it wants us to calculate the density. So we would divide 1.5 kilogram density is equal to mass over volume. So we have 1.5 kg divided by 405. Now we need to convert this kilogram to grams because the question wants it in grams. Calculate in grams. So 1.5 kg means 1,500 grams. And we're dividing that by 405. and that gives us an answer of 3.7 3.75 grams per centimeter cube. So that is our answer there, 3.75 grams per centimeter cube. All right. And so, again, this is how we answer our question. The area of the cross-section multiplied by the height. Here I said base, it's actually cross-section because it's not always base. But we do our calculation, we find the cross-section multiplied by the height or the length. All right, moving on to our final question. In this one, it is a triangular prism. And so the first part of the question says, calculate the area of the triangle. The area of the triangle, you notice here, is the cross-section. So this triangle is the cross-section. And once we find the cross-section, then it becomes easy to calculate the volume because the area of that cross-section multiplied by the height or the length gives us the volume. So you need to know how to calculate the area of simple shapes. And you use those simple shapes because the cross-section is often a simple shape. A triangle, a square, a rectangle, a circle, a semicircle, a trapezium, whatever it is. And we use that knowledge to do our further calculations. So here we go. The area of the triangle ABC, we use this simple formula. Base times height divided by 2, or half base times height. In this case, it's a very simple calculation. 4 times 4 divided by 2, which gives us 16 divided by 2, which is 8 centimeters square. So that is the area of our triangle, and it is our cross section as well. Part B now is asking us to calculate the length of the edge CD. So the question tells us that the volume of the prism is 72. Remember again, the volume is equal to area, AREA, of cross section times the height or length. And so in order to find CD, which is the length, we're going to be using the fact that the area of the triangle times the length would give us the volume. So 8 times CD would give us our volume of 72 centimeter cube. And so CD, therefore, is 72 divided by 8, which gives us 9 centimeters. I want you to pay attention to something that I've observed, that in many of these questions, CXC likes to ask you to calculate the height of these shapes. So in using your formula, whatever formula you're using, know how to transpose your formula. Know how to not just calculate area, but to use that formula for area to calculate radius. Not just to calculate perimeter, for example, but to use that formula also to calculate radius. And in the case of calculating the volume of a circular cylinder using pi r square height, that you don't just plug the numbers in and you know how to calculate the volume, but you can turn that formula around and calculate the height or calculate the radius given the other parts of the other numbers that are related. That's it for now. I hope that having gone through these questions, you would have developed a better understanding of how to go about calculating volume and dealing with density in these kind of questions. Thank you for watching, and do continue working hard as you prepare for your exams.